Hello class, in today's video we're going to be going over recurring and terminating decimals. The learning intention of today's video is we're going to understand the difference between the terms recurring and terminating decimals, and lastly we're going to understand the symbols used to indicate recurring decimals. So let's look at the first topic of today's lesson, which is about recurring decimals. So what is a recurring decimal? The word recurring essentially means repeating. So recurring decimal is a repeating decimal which has a repeated pattern. Now, a decimal may have more than one recurring or repeating digit, and we often use the three dots over here to indicate that the number keeps on repeating forever. Now, I've got 5 examples over here that are examples of recurring decimals. If we look at the first example, this is an example of a recurring decimal because, as you can see, it has the number 7 just repeating it by itself. So this has a recurring or a repeating 7. In my next example over here, notice that the numbers 5 and 6 just keep repeating onwards. So therefore, this is also a recurring decimal as well. In the third example over here, although this contains 2 9s which repeat itself, this doesn't keep on repeating itself continually. Instead, as you can see that the numbers 3 and 4 keep on repeating itself. So this has a recurring 3 and 4. The second last example is 0.363636. We can clearly see that has a repeating 3, 6. And for my very last example over here, now notice for this one over here, this is repeating in has 4 repeating digits. So it's got 8, 0, 1, and 9. So this is another example of recurring decimal. I just want to show you that for particularly on the last example, a recurring decimal can have more than 2 repeating digits. So now what we can actually use, instead of listing all those repeated digits, we can actually abbreviate, meaning we can actually shorten the actual numbers by using either dots or a bar. And I'm going to show you that in this example over here. So what I mean is, instead of just writing 0.777777 and just wasting a lot of space, what we could do instead is we could actually use a dot just to shorten this over here. So another way we can write 0.777 is writing 0.7 with a dot on top, and having a dot on top indicates that that specific digit is going to be repeating itself forever. Looking at my next example, notice that you've got 2 repeating numbers. Now, if there are 2 or more repeating digits, you either use 2 dots or a bar. So I'll show you how we can actually do that. Because the numbers 5 and 6 are repeating, I'm going to be putting a dot on both 5 as well as 6. So that's if you were to use 2 dots. Alternatively, if you don't use that, you could actually use the bar, meaning a dash instead. So you just put a dash for the digits that are recurring, and I generally prefer you to use the bar. So you can use any of one of these answers, you don't have to include both. I recommend using this over here, but for the purposes of this video, I'm going to show you 2 examples, or both of these examples. In the third example, 14.99343434434, because 3 and 4 are recurring, so I'm going to put 2 dots on 3 and 4, or alternatively, I could put a dash on top of that. 0.36, again, I could put these 2 dots. And for my very last example over here, notice that I'm putting a dot on the first digit as well as the last digit in that group over here, because that's the repeating group. So I'll put a dot on the first digit as well as the last digit if I'm using the 2 dot method. Otherwise, I'm putting a dash over all the numbers that are recurring in this case. So I'm putting above 8 and all the way to 9. So these are just ways that we could actually do this. Now, if you didn't understand what I was showing you in the previous slide, this slide over here summarizes how you could actually use the recurring decimal notation, the symbols, to express that a decimal is recurring. So when you say there is a 1 repeating digit, all you need to do is just use a single dot on top of that digit that is repeating. So for instance, if the number is 0.899, notice that the digit 9 over here is repeating. So we don't really need the other numbers at all. We just put a dot on top, which is why this over here is the answer. Now, when you have 2 or more repeating digits, what you could do is you could either use 2 dots or a bar, which means a dash, to indicate that the group of numbers is repeating. So if you're using the 2 dots, the first dot indicates the first number in that group that's repeating, and the second dot indicates that the last number in that particular group is repeating. So for instance, if this is your number over here, notice that you can see that the numbers 523 are repeating. Because 5 is the first digit in that group of 3, you put a dot on the 5. And since 3 is the last digit in the group, you put a dot on the 3, which is why you can either write your answer as this. Now, to get this answer here, essentially, can you see that if you connect those two dots over there together, this produces the bar? So using any of these answers over here is appropriate, but I recommend just using the dash because it's just a lot more easier. Let's now look at some more examples of where we could actually use the recurring decimal notation to abbreviate the following numbers. So we're going to be using either the dots or the bars to shorten the following recurring decimals. So in the first example over here, can we all see that we can see that there's a repetition of the digit 6, and since there's only one repeating digit over here, all I'm going to be doing is using a single dot. So therefore, what I do is I put the dot on top of the first 6 I see, and I don't really need the other numbers at all. So therefore, my answer in this case over here is going to be 2.506 with a dot on top of the 6. Now, for my second example over here, I look for, again, what I want to do is I want to look for the repeating digits. And in this case over here, the repeating digits are the 0 as well as the 1. Because I've got 2 or more repeating digits, I could either use the 2 dots or the bar, and I'll show you how we could actually do both of them. So in this case over here, because it is repeating, I don't really need the other numbers at all. I could either put a dot in between like this, or I can connect those 2 dots to create that little bar. So therefore, my answer in this case over here is going to be 0.00301 with the 2 dots like that, or with the bar as shown as well. Now for my next example over here, notice that you've got a group that is repeating. And because this group is repeating, I can therefore cross this out over here and use the bar as shown like this. So use either one of these examples, but I always recommend using the bar. And for the last example over here, although I've got the 222 over here, I can clearly say that the repeating digit that keeps on going forever is the digit 5. So therefore, because I've got one single digit, I just put a dot over here like this, erase the other digits, and therefore this is going to be my answer. Alright guys, now it's time for you guys to check your understanding. So I want you to please answer these 4 questions over here. I don't think it will take more than even 5 minutes to write down and answer the questions. So please pause the video right now so you can attempt it by yourself and then compare your answers with mine afterwards. Alright, so now that should be more than enough time for you guys to actually answer the questions. Now for this question over here, these are the answers that you should be getting. So hopefully you've got the answer. If you don't have the answer and need some clarifications, please email me. So for my next question over here, which of the following is not a recurring decimal? So the question wants us to find a number that doesn't actually keep on going forever and forever. So in the case over here, I want you to please pause the video and pick an answer for me to see whether your answer is correct. Alright, so now I'm going to be going over the answer for this particular question over here. So I'm trying to find a number that doesn't keep on continuing on forever. So the answer for this question over here is going to be B, and the reason why this is not an example of a recurring decimal is because it doesn't actually use a symbol, any form of symbol that indicates that the 3 is repeating. So it stops at the 3, so that indicates that there is no more numbers after the 3, so therefore this is not an example of a recurring decimal. For part A over here, you can clearly see that that dot indicates that 9 is repeating, this bar indicates that 2 and the 1 is repeating, and in my last example, we could also use these 3 dots over here to indicate that it's going to repeat 4 and 5 in this case as well. In my next example, or in my next question over here, you also again I want you to identify which of the following is not a recurring decimal. So please pause this video and answer the question. So for this question over here, the correct answer is going to be 0.25. Now again, the reason why this is not a recurring decimal is because there's no digits after the 5. So therefore, this indicates that the number doesn't continue on forever at all. Okay class, because there's no textbook questions for this particular topic, I want you to please answer these questions inside your exercise book. I recommend that this will probably take no more than 10 minutes. So please pause this video right now so you can answer the questions. So what I want you to do is I want you to use the recurring decimal notation, so using the dots or using the bars to represent and abbreviate the following numbers. So please pause this video right now so you can answer the question and then compare your answer with my answers. Alright guys, so if you guys answered this question, what you should get for the first answer is 0.5 dot, the next one is 0.1 dot, This one is 0.12 like this. I'm just going to use a bar because that's my preference. The next one is going to be 0.36 bar. This is going to be 0.91 bar. This is 0.72 bar. This is going to be 0.125 bar. 0.621 whole bar. The bar should go over there as well. This one over here should be 0.204 whole bar like this. This is going to be 1.5 dot. In this case over here, there's two repeating digits, so it's going to be 1.45 and the bar over the 4 and the 5. The next one's going to be 1.24, only one repeating digits. This next one's going to be, because I can see that there is a repeating 7 and 1, therefore this is going to be 2.071 and a bar over that's just a 7 and the 1. Second last example is going to be 1.359 with a dot on top of the 9. And for the last question, 3.8123, and I'll put a the bar on top of the 1 all the way to the 3 because the 1, 2, 3 keeps on repeating. So this is the answers that you should be getting for this particular for these particular questions. We're now going to be moving on to the next topic of today's lesson, which is about terminating decimals. Now, a terminating decimal is pretty much the direct opposite of a recurring decimal. It's a decimal that actually ends this time. So a terminating decimal may have some repetitions, but it does not continue forever like a recurring decimal. So the following examples over here, the following 5 examples are examples of terminating decimals. The reason why these are considered to be terminated because they don't have any other symbols like a 3 triple dots or a dot on top or a bar to indicate the number keeps on going. So 2.5 stops there, 10 also stops. Now, although over here, although this contains 2 8s and repeats, it doesn't have any other symbols to indicate this number keeps on going. So therefore, this is an example of a terminating decimal. Similarly, 4.660 is a terminating, and 39.55 again is another example of a terminating. Although it has some repetitions, it doesn't have any symbols to indicate the number keeps on going. So what I'd like you to do right now is I'd like you to please copy down this particular table inside your exercise book. Now, what's really great about this question over here is that I kind of want you to... Oh, hold on. Now, class, this particular table is going to be really, really important for your upcoming post-test. So what's really great about this table is that, or what I really need you to know about this table is I kind of need you to know these fractions and decimals. So these are equivalent. So another way of writing, for instance, 1/2 is 0.5 as decimal. Another way of writing 1/3 as a fraction as a decimal is going to be 0.33 or 0.3 with a dot on top. So you kind of need to be familiar with some of these fractions as well as its decimal form because you might need them for your post test, but alternatively, you could also use a calculator as well. Now, for this particular question over here, what the question wants you to do is in this last column, you need to write whether the following decimals is an example of a recurring or a terminating decimal. So please give yourself 10 minutes to copy down this table and answer it. And if you do this, then please continue watching the video to see whether your answers are correct. Now, if you've done this correctly, these are the answers you should be getting. So I'm hoping that you guys aced through this. And now we're going to be moving to the last topic of today's lesson. So the last topic of today's lesson is checking whether a fraction produces a recurring decimal. So the way that we do this is we actually need to rely on a calculator. So I'm going to be showing you how we can actually do this over here. So for my first example, I've got a half. So what I'm going to be doing first is I'm going to write half over here and then press equals. Now to get this to a decimal, I press this button over here, the SD, and that gives me 0.5. 0.5 is an example of a terminating decimal. So I'm going to write TD. For this one, the next one also gives me a half, which is an example of a terminating decimal because the number stops after the 5. 3/4 in this case of it is equivalent to 0.75. There's no numbers after the 5, so therefore this is an example of a terminating decimal. The next number, 2/5, that's equivalent to 0.4, so therefore this is also an example of a terminating decimal. 1/3. This one is a number that you should be familiar of. This over here, as you can see, keeps on spamming the number 3. So therefore, this is an example of a recurring decimal. 3/8, if you put this directly into a calculator, notice over here that this is an example of a terminating decimal because there's no number after the 5 at all. 5/12, if you put this into the calculator, I just want to quickly draw your attention. If you put this into a calculator, they've actually rounded the last digit over here, but this is an example, again, of a recurring decimal because there was a lot of sixes. And for the last example, put 3/7 into the calculator, you're going to get this answer over here. Because there's no repetition at all, this is clearly an example of a terminating decimal. Perfect. So what I'd like you to do right now, guys, is after you've answered those questions, I want you to quickly answer the questions on the exit ticket. Now, there's only about 14 multiple choice questions, so it's not going to take you way too long at all. This is pretty much the end of the today's video, guys. Thank you guys for watching. Hopefully this video helped you. I'll see you again in the next video. Bye.